Welcome everyone to a Bachelor in IT, Subject Information System Security BIT 2333. We will discuss today's session with topic number 4, discretionary versus the mandatory access control. Okay, so today we will discuss deep dive into the mechanism that keeping the digital assets safe, starting with the bedrock, the foundation of system protocol, which is the access control. Okay, so the foundation of access control. So access control is the mechanism to regulate on how we handle the users, how we handle the system that will interact with the sensitive organizational resources. Okay, so it is the core that the system enforce a permission that will ensure that only authorized entities, authorized user, or authorized software can view or can modify your data. So we need to have the proper access control implementation to prevent unauthorized data leakage as well as the accidental system corruption. So you can think like the digital lock, a key, and also a security guard that are guarding your network architecture. And the designing an effective access control strategy, it is very much requiring a clear understanding and user roles and your data sensitivity. So without the access control, you are leaving your enterprise or your company vault door wide open to intruders. Okay, discretionary access control concept. So what is the discretionary concept? Okay, so our first major access control model, which is the discretionary access control, or in short we call it as DSC. This discretionary access control able to grant you, a resource owner, the authority that he be able to decide who can access or who can enter the files and resources in his organization. Okay, so if you create a file of a document, you are the owner and you have a full discretion to pass the access permission to other users without administrative oversight. So this is basically the model that offer a high flexibility, making it extremely popular in a standard commercial operating system where the user need to share files quickly and easily. Okay, however, convenience come with a heavy security tax. So the discretionary system are vulnerable to malicious software propagating through user granted permission. Okay, so if a user get infected with malware or any virus, the virus will inherit all the access rights of the user. Okay, quietly it will be able to spread permission or corrupting file across shared directories. Next up, we have the mandatory access control concept. Okay, so in contrast, the DSC, the discretionary access control, we have the mandatory access control, the MSC. Okay, so the MSC, the mandatory access control, restrict access based on system-wide policy established by a central authority, basically the owner or the administrator. Okay, rather than an individual file owner. So in this model, user cannot alter or share a security permission regardless of file ownership status. So if you own a file, you still cannot grant someone else access if they lack the required clearance. Okay, so this model utilizes a strict security levels assigned to both subject, which is the user or the process, that belong to a software, and a system object, which is the files, the folder, or the hardware. And the MAC provides a maximum security and widely used in military, widely used in intelligence, in government, in universities environment, where the data confidently is a matter of national security. Next up, we have the access control list fundamental. So how do the operating system in your computer actually track who has the access to what? Okay, so one of the primary method is by using the access control list, or the SCL. Okay, so this is one of a popular key term, the SCL. It is the access control list. So the access control list are the data, the structures associated with system object that specify authorized user permission. So we have each entry in this SCL that able to identify a specific user or specific group, and the allowed actions such as the user or the group able to read, able to write, or able to execute. And the operating system will check the access control list whenever a user attempt to open or modify a file. Okay, and a critical administrative challenge here is the maintenance. Okay, maintaining the SCL. So maintaining the SCL list to prevent unauthorized privilege creep over time. So this is the dangerous phenomena that the user accumulate more and more permission as they change the role without the old permission have been revoked. Implementation of access control list. So when we are implementing the SCL in real-world file system, the administrator will gain a granular permission management capabilities. That this will go far beyond basic owner group world categories. So the administrator can assign a specific right like read, write, or execute, or maybe delete to individual account. And in a large enterprise environment, managing an individual account become impossible. So the team use group access control lists to simplify administrative management workloads. And furthermore, because of the configuration drift, regular auditing of access control lists ensure that the outdated or the excessive permission are removed promptly. Routine audits are your best defense against insider threat and injuring access path. Okay, next up we have the role-based access control architecture, RBAC. Okay, this is a role-based. Okay, so why role-based? Because we want to solve the scaling issue of individual SCLs that we have discussed earlier. So we have the modern system that heavily rely on the role-based access control, or the RBAC, and the RBAC assign a permission to a specific organizational functions rather than an individual user. So the employee placed into the roles such as database administrator or maybe a financial analyst. Okay, and it able to inherit the predetermined access right associated with those positions. So this approach significantly simplifies the user onboarding, offboarding, and role change administrative permission. So when an employee change department, you simply move them to a new role rather than readjusting dozens of individual file permission. Importantly, the RBAC aligns closely with organizational structure and the principle of least privilege. Okay, next up, attribute-based control access control system. Okay, the ABAC. So moving beyond a static role, we reach the cutting edge of authorization, which is the attribute-based control access control, or the ABAC. So the ABAC evaluates the policies that containing a dynamic characteristic before granting system access. And these evaluated attributes can include user identity, device location, time of a day, even the network connection type, as well as the data classification levels. So this model offers extreme contextual flexibility on a modern cloud and distributed computing environment. And the decisions are calculated in real time by policies to enforce the engine based on current situational parameters. So for example, like you have the allow access to medical record only if the user is a doctor, and using a hospital issues tablet, only hospital device. Inside the facility, meaning we activate the GPS location, and during regular shift hour, during some working hour. Okay, so this is the attribute-based access control. We specified a parameter. So by doing this, we're able to control the access of that particular user. Okay, next we have the overview of conventional encryption algorithm. So we are now moving from access control to the cryptographic foundation. So why cryptographic? Because that is the method to protect data in transit and at rest. Okay, so we have the conventional encryption algorithm that use the mathematical formula. By doing this, we're able to transform the plain text data into a secure ciphertext. Okay, ciphertext meaning that you are unable to read unless you have the key to open the text. Okay, and we have a symmetric algorithm that relies on a single shared key for both the encryption and decryption operation. That is the symmetric algorithm. Okay, remember, symmetric algorithm have a single key for both encrypt and decrypt, and this algorithm are priced for the high computational speed when securing a large volume of data. However, they come with a catch. The secure key distribution is the primary optional challenge when we are deploying conventional encryption system. If both party, the sender and the receiver, need the exact same secret key, how do you hand them the right key over an insecure network? So that's the problem with symmetric algorithm. Okay, the data encryption standard. So to understand the modern cryptography, we must look at the history, the past history. Okay, starting with the data encryption standard, the DES. This is the old school of data encryption algorithm, and the data encryption standard DES historically established a foundation of symmetric block cipher, the shared key between the sender and the receiver for commercial application. Okay, so it can operate a 74-bit lock of data using a 56-byte effective encryption key length. So while we change revolutionary for its time, the advance in computer power eventually render the key size vulnerable to brute force this decryption attack. And the specialized hardware cracked the DES key in a matter of hours. So despite its retirement, it laid the mathematical groundwork for a modern block cipher development. Okay, so we learn from the DES technology, and we're able to create a new safety method by using a cryptography. Okay, so we have the replacement of DES, which is the idea of encryption algorithm. So alternative block cipher emerged, such as the internal data encryption algorithm, the IDEA, International Data Encryption Algorithm, IDEA. Okay, so the IDEA provide a strong symmetric block cipher alternative compared to the older standards, compared to the DEA. Okay, and it processed that block, the data block, using a robust 128th bit of key length to enhance the security. And the IDEA employs a clever algebraic structures combining operation from different algebraic group like the modular addition, multiplication, and bitwise exclusive, or the OR operation. We do this to achieve the high cryptographic confusion and diffusion. So because of this strong security profile, it is widely utilized today in early email encryption application like the PGP. Okay, and we have the cheaper block chaining mode. So using a block cheaper like the DES and AES, this require a mode of operation to handle data larger than a single block. So one of the most common is the cheaper block chaining mode, also the CBC. So the CBC mode enhances the security for XOR ring, which the plain text block with the previous cheaper text block before it is encrypted. So this mathematical chaining able to ensure that the identical plain text block encrypt into completely unique cheaper text output, and it able to hide the pattern in the data. And we have the initialization vector, the IV. It is required to randomize the encryption process for the very first data block, and you can note that the error propagation is a characteristic trait here. So any single bit error in transformation will corrupt the current block and affect the decryption of the next. Okay, so location of encryption device. So when we are designing our network, we need to secure the network, and you as a network engineer must decide where the encryption is physically and logically implemented, the location. Okay, so the hardware encryption device can be deployed at network boundaries to secure your data moving across the link, and also alternatively the end-to-end encryption able to press the cryptographic function directly on user endpoint before the data transmission begin, and ensuring the data remains encrypted through every intermediate hoop. Okay, and link encryption secure all traffic that pass between a specific physical nodes on a telecommunication network, and choosing the correct hardware location depends entirely on performance requirement, latency limits, and as well as the organizational risk exposure profile. Okay, the link encryption versus end-to-end encryption. So let's see the differentiation between these two strategies, and it is a frequent exam and design logic. Okay, and the link encryption protect data and routing headers as they travel across individual physical communication segment. So every time a packet hits an intermediate router, it is decrypted, inspected, and re-encrypted for the next link. So the end-to-end encryption, by contrast, it protects the actual payload data continuously from the source sender to the ultimate destination receiver, and the intermediate router can read routing header on link encrypted network to direct traffic, but they cannot inspect end-to-end payloads. So combining both the method provide comprehensive defense in-depth protection against any physical wiretapping or any packet interception. Okay, cryptographic key distribution challenge. So we know that as we have discussed earlier on the key distribution, we know that why it is considered the ultimate cryptographic hurdle. Securing sharing a secret key between communication parties over an insecure network is a fundamental cryptography challenge. So you can think like if a key distribution channel is compromised, the entire security of the encrypted communication will fail instantly. And furthermore, the manual key distribution do not scale effectively, meaning that in an enterprise level or organization level, the thousands of employees, the number of required pairwise key grown exponentially with the formula of n minus 1 divided by 2, because of human cannot manually manage thousands of static keys securely. So we need to have an automated protocol that necessary to deliver and update the key safely without human administrative intervention. Key distribution center. Okay, so to solve the scaling nightmare, the problem with a large thousand of connected nodes in the network and the key distribution, so our system introduced a key distribution center, or the KDC. Okay, so the key distribution center, the KDC, acting as a trusted third party that the KDC able to manage and issues temporary session key to users, and the user authenticate with the KDC first before requesting a short-lived cryptographic key to secure talk to other nodes. So this is the architecture that dramatically minimizes the number of master key that individual must store and protect manually, and you only need to share a master key with the KDC. And the industry standard example of this architecture is in action is the Kerberos authentication protocol used in enterprise network. Public key infrastructure and key management. So while the KDC work brilliantly in closed enterprise network, open environment like the internet require a different framework, which is the public key infrastructure, or the PKI. Okay, so the PKI utilize the asymmetric cryptography and also use certificate authorities, the CS, to manage the digital certificate. And the certificate authorities able to verify the user and the server identities before issuing a digital signed public key certificate. So this infrastructure successfully solved the key distribution problem over open network like the internet by establishing chain of trust. And the lifecycle management within the public key infrastructure is very important, vital, and include secure key generation and schedules certification, renewal, and prompt reliable key revocation when the certificate are compromised. Access metric models. So to tie our access control concept back together theoretically, the security engineer used the access metric model. So the access metric is a theoretical security model mapping subject against object to define permission. The row represents user and or the process from a software, while the column represent files, device, and system resources. So we can slice this metric into two ways. Number one is the column-wise slice that attach the specific system object with access control list with the SCLs, and the row-wise slice will help the security by individual user or process give us the capabilities. So you can think of a token or tickets that grant you a specific rights. Emanations and physical security of cryptographic gear. So security is not just the software and keys. It also involves a physical hardware handling cryptography. So the cryptography device or the hardware must be shielded from electromagnetic emanation. The emanation is the unintentionally radio frequency signal that could leak secret key data to nearby surveillance equipment. So we have the Tempest security standard that govern the rigorous shielding requirement for hardware handling classified cryptographic materials. And the physical security enclosure protect the cryptographic processor from invasive hardware probing or maybe micro probing and tampering attack. So if a device detect a physical breach attempt, automated zeroization function will wipe all sensitive key from memory instantly. Okay, next up, the auditing and monitoring access control. So as we near the end of our topic, we look at oversight, which is the auditing and monitoring. Continuous auditing and access control log will help you to secure your team, detect unauthorized permission escalation attempt in real time, and monitoring tools record every instant where a user attempt to access restricted files or system. And very important, failed access attempts are critical indicator that can signal active brute force script, credential stuffing or insider threat. And furthermore, the compliance from frameworks such as the PCI DSS, HIPAA, and the ISO standard ISO 27001, these able to mandate a regular review of access logs to prove a continuous adherence to your internal security policies. Okay, so we come across the last slides of this topic, which is the policy enforcement and system integrity. Okay, so we can conclude that by looking at the policies enforcement and system integrity, we can effectively use the policies enforcement that able to bridge the gap between the high level organizational security rules and technical access control on the ground. And the operating system must strictly enforce the access boundaries without allowing user bypass this loophole. And regular vulnerability assessment, by doing this, you're able to ensure that the access control configuration and the cryptographic tables have not degraded or drafted over time due to the human error or administrative shortcuts. And maintaining the system integrity guarantee that your access control table will remain protected from unauthorized tampering. And so that's all for our topic. So we will see on the next topic. Okay, have a nice day. Thank you.